Hello everyone, welcome back to Mahaboard Examiner. Today we're going to start a very interesting and important lesson of class 10 science, gravitation. We will learn how objects attract each other, why things fall, what keeps satellites on the orbit, and many more. So students, let me ask you a simple question. Why does an apple always fall downwards and not sidewards or upwards? Because the earth pulls every object towards the center. This pull is called as the gravitation force, and this is happening because of the natural force called gravitation. Without gravity, objects would float away like the space. So let us see what is gravitation. Gravitation is a force of attraction that exists between any two objects in this universe. This means the earth pulls us towards it, but at the same time we also pull the earth towards us. The only difference is because the earth's mass is huge, we cannot notice its movement. So in short, gravitation is the force with which every object in the universe attracts each other object. This is the same force that keeps the moon revolving around the earth and the earth revolving around the sun. So let us see about Sir Isaac Newton. Sir Isaac Newton, who was from 1642 to 1727, discovered the law of gravitation. He explained why the planets move in the orbit, gave three laws of motion, which we will study later, and he invented calculus and built a reflecting telescope. This brought a different side of science forever until now. Why is gravity universal? As we already know, gravity is not just limited towards the earth. It pulls an apple down to the ground. It keeps the moon in the orbit around the earth. It holds planet in the orbit around the sun. It binds the stars and the galaxy towards each other. Gravity acts everywhere in the universe, from a small pin to the galaxy. So let us see what is circular motion and centripetal force. When an object moves along the circular path, we call it circular motion. For example, a stone tied to a string and whirled, the motion of the planet, or even the satellite around the earth. Remember, the velocity of the object is always tangent to the circle. That means if you cut the string suddenly, the stone will fly away in a straight line, not to continue in a circle. So, for circular motion to continue, same force must be applied on the object towards the center of the circle. So now let's see what is a centripetal force. The force that pulls the object together to the center is called the centripetal force. The word centripetal itself means center seeking. The force doesn't increase the speed, but it constantly changes the direction of the motion, keeping the object on a circular path. If centripetal force is removed, the object will move in a straight line or tangential to the circle. So let us see some everyday examples. Example 1. A stone tied to a string and rotated, as I already said. Example 2. The earth revolving around the sun due to the gravitational force. Example 3. Satellites staying in the orbit around the earth. Example 4. Even vehicles turning on a curved road. Friction is provided centripetal force. Before Newton explained gravity, a scientist named Kepler studied how planet moved around the sun. He gave us three important laws of planetary motion which helps us to understand the path and speed of planets. He said, planets move in elliptical orbits with the sun at one focus. The line joining the planet and the sun sweeps equal areas in equal time. Square of time period is directly proportional to the cube of its distance. So as I said, these 3 points are the 3 laws of Kepler. The first law is called the law of ellipsis. The second law is called the law of equal areas, and the third law is called the law of periods, which you will learn further. After Kepler gave his laws of planetary motion, Sir Isaac Newton explained the reason behind them. He said that every object in the universe attracts each other object with a certain force. This is called the universal law of gravitation. The law statement says that every object in the universe attracts each other object. The force of attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This law is written as F is equal to G into m1 into m2 divided by r square, as I already said, where F is the gravitational force, m1 and m2 are the masses of the object, and r is the distance between them. G here is the gravitational constant. As I already said, the Earth's gravity and G. Let us see about it. The Earth attracts everything towards its center, which is called as the gravitational force. It is the force that makes the object fall down, gives us weight, causes ocean tides, and even keeps satellites revolving around the Earth. When an object falls towards the Earth, it accelerates due to gravity. This acceleration is called g. Its value is near the Earth's surface is about 9.8 meters per second square. An important point, g is the same for all the objects, whether it's heavy or light. All the objects fall with the same acceleration, ignoring the air resistance. Example, a ball and a stone fall together in vacuum. So let us see what is free fall. When an object falls only due to gravity, we call it free fall. In free fall, the air resistance is ignored. So let's see an interesting fact. A feather and a stone fall at the same rate in vacuum, and this is proved by Galileo. Astronauts and satellites are also free fall in the galaxy. So let's see what is escape velocity. Escape velocity is the speed needed to leave the Earth without falling back. For Earth, it is about 11.2 kilometers per second, much faster than rockets we usually imagine. And the exact definition is minimum velocity required to escape the Earth's gravity, and the formula is given as VE is equal to square root of 2 gm by r. So let's see a little about satellite and spaces also. A satellite is any body that revolves around a planet. For example, the moon is the Earth's natural satellite. Humans have also made artificial satellite which we launch into the orbit around the Earth for different uses. Let us also see about the motion of satellites. Satellites move around the Earth in circular or elliptical paths. Why don't they fall down? It's because Earth's gravity provides them centripetal force, and at the same time the satellite speed tries to move it tangentially. This balance keeps the satellite in the orbit. So yes students, when we see about gravitational waves, apart from Newton's law, Einstein gave us a deeper understanding of gravity in his general theory of relativity. He predicted the existence of gravitational waves, which is ripples in the space-time. These waves were actually detected in 2015 by LIGO scientists, and the discovery won the Nobel Prize in 2017. So what are gravitational waves? Gravitational waves are ripples in the fabric of space and time, just like ripples in water when you throw a stone. They are produced when huge cosmic bodies like black holes or neutron stars collide or explode. These events are so powerful that they shake the universe itself. These waves move at a speed of the light, but they are extremely weak. When the strongest gravitational wave changes the distance by less than a width of a proton. That's why detecting them is very difficult. Why are gravitational waves important? Because they give us a new way to study the universe. Normal telescope cannot see black holes merging, but gravitational waves can show us that. This has started a new field called gravitational wave astronomy. So let us see some key topics of this chapter. In this chapter, we will learn about the Newton's law of gravitation, acceleration due to gravity, free fall and examples, escape velocity, satellite and weightlessness, and gravitational waves. And so, with the closing thought of this introduction of the lesson gravity, we can see that gravity is not just a force, it is an invisible thread holding the universe together. Without gravity, there would be no stars, no planet, and life. So, yes, students, today we understood the basic of gravitation, how Newton explained the universal law, the idea of Earth's gravity, and how it affects everything around us. In the upcoming videos, we will go deeper into this lesson with more concept and solved examples. If you found this video helpful, don't forget to like the video, share it with your friends, and subscribe to the channel Mahaboard Examiner so that you will never miss any of our upcoming lessons. See you in the next class.